はい、この時間
So hello everyone. So this is a panel discussion titled Issues and Future Prospect for the MySQL Environment Managed by Yahoo in Japan and Online. So first we would like to start with introductions of ourselves. So maybe me first. My name is Harachi. I am the DBA for MySQL's one team at Line. Momochi-san, Kushi-san called me when I was on the way to home, and I was invited to these sessions all of a sudden, and I'll monitor their discussions. My name is Makoto Sato from Yahoo Japan. I belong to Database 1. So I am responsible for DBA and DBRE. So those who are not familiar with the DBRE, I'd like to explain. So DBA is, as you know, is a database administrator. So they are in charge of the operation, maintenance, and tuning. But the DBRE is a database reliability engineering. So we are in charge of the improving reliability of database. We provide monitoring and audit and creating BCP, providing education, training. Okay, nice to meet you, everyone. Thank you. So, my name is Tsubasa Tanaka. I am the Yahoo 0825 in Internet. I am DBA at the database department, MySQL 1 team at the Line Corporation. So I am doing fine-tuning for database, and we are in charge of the MySQL. So today we're supposed to talk about MySQL. Nice to meet you, everyone. Okay, so first, the Yahoo Japan Line, the database environment that you provide for your developers. So first, we are going to introduce database we use. Maybe I'd like to ask Sato-san. Okay, in Yahoo Japan, so we use MySQL DBaaS for internal use. We call it DBAs. It's on the website. You simply click on the screens, and you see the MySQL DBAs on the screen. Yes, and also the domain name is DBAs as well. So it's easy to identify. Yeah, in our domain name is also DBAs. And it says an HA exactly. So when it comes to the configuration, we have the per corner extra DB, PXC. So everything can be a master. We have a cluster. Everything can be a master. And for infrastructure, we have OpenStack. So DB component Trove. Based on that, we have the private cloud. What can Trove do within OpenStack? It's a database component. Okay, it is component dedicated to database. So we use it. So when it comes to OpenStack, so when we developing our database, so private cloud application server was established in OpenStack around that time, and then so we deploy horizontally by using Trove. So if we use the Trove, we are able to construct a system in the DBAs. So MySQL version, what is the version that PXC can handle? 5.6 and 5.7. So 8.0 will be also possible. Right, yeah, I'll talk about that later. So, but 8.0 cloud cluster base is one of the future visions. Okay, thank you very much. Okay, that was about the line side, and our side we have the what is called a DBAS for MySQL. We have on top of the OpenStack we have Vada. So Vada is a wrapper. So on the Vada platform we have a database component that is equivalent to Trove, I believe. That is called DBAS for MySQL. And that's for the HA. It's Tsubasa PXC. Vis-a-vis, we have the vanilla same-sync replication base, traditionally one primary, and we have multiple replicates. And if there's a failure, then most advanced replica takes over to the change master source 2. So this is very traditional async base. Okay, can I ask you a question? So what about the orchestration tool? Yes, well, yeah, orchestration tool is there. That is Grain HA. Well, Grain HA. So this is on top of the Vada. So I'll talk about that later. And Vada VM is being supported only. Physical machines are not supported. What about DBAs? So it's under the OpenStack, so physical machines can be supported? No, they can't. It's a VM-based operation, therefore there are no physical, or there's no support for physical machines. Well, DBAS for MySQL, the one generation before this, we had like similar to DBAS for MySQL, which was able to support physical machines. So we were looking for a way to support physical machines, but maybe, yeah, in the future it might be possible. Okay, so virtual machine and physical machines, those are the topics we have been discussing. And then, so we have the VM based on DBAs. But in addition to those, if something special is necessary or required, what can you do? This is for Yahoo Japan, exactly. So this is a chart to explain that topic. So at Yahoo Japan, MySQL and Oracle, Cassandra, and the Redis. So those are online database PF. And so online is a key here. So low latency, because response must be sent back immediately, and it has the high availability and 4.9 level of operability. Those are requirements. Those shouldn't stop, must not stop. So this is what we try to achieve.
So it's totally clearly different from the analysis one. So once it's hit, we need to respond back right away. So that's the definition of the database. So this is how we have this structure. So here we have a dedicated PF team. So they are engaged in the development and maintain and do the version up. So there's a dedicated organization for that purpose. And so for us to use database, so there are cases that is not rightly using the database. For example, the skill of engineer, it's limited to Oracle. So RDB is used for Oracle. So we don't know about those backgrounds. So they simply say they want to use, so we simply hand over. But apparently, this is a database just for cache just for database. But in MySQL, the cache is being introduced. So that happens. So it's included in our RDBA. So, but Cassandra can serve the purpose. So we have a flowchart here so that the people can select the right one. So we decide the rule before we provide. So if you want to use MySQL, so it's not for the cache purposes. It's a relational database. So it's a QPS within 1,000. So it's 1,000 per unit QPS. And so capacity. So from the easiness of using the open, so we limit to 1 tera. So as long as 1 tera, it's within 1 tera, then DBAS should be used. So we put a limitation or rule. So there is a certain threshold that DBAS cannot be used. So there is a 3-measure structure for DXC. So 1,000 QPS for each unit, then it's going to be 3,000 altogether. So for one cluster, it's 3,000 as a maximum. So 3 units are the fixed one, yes. So for cluster DB, so QPS is not realized based on the structure. So everything is master. So without any latency, the master needs to synchronize each other. So for the writing purpose, QPS does not serve. So that's why we said 1,000 for QPS. So if you want 3,000 QPS, then we have 3 units. So 3 or 4 units of shadow to be structured. Okay. So that requirement of 1,000 or 1 tera. So if we are unable to satisfy that requirement, then what happens? So in that case, the area that DBAS can cover is, for example, like 1,000 QPS, and the capacity was is 1 tera. So the system that exceeds those capacity, then we are unable to match. So the master replica structure needs to be created. So we supplied the VS, but it is not DBAS. So we are unable to create by clicking on the screen. So a certain part is automated, but we need manual work to create the platform. So the image I have is for the inventory, we put the name of machine, and if DB operates, then you're able to establish the structure. Yes, it's close to that. So we have an automation too. So as long as we are able to write the configuration, then we are able to structure, but the network setting needs to be done manually. So we are trying to expand the area of coverage based on that. So for that, we can cover maximum 5 tera, and 10,000 QPS is something we can manage. So we are able to add lead replica with that. So we prepare V2 for that. So it's not as a service, but you're able to support based on the structure of MySQL. So if it exceeds the capacity, what happens? So as an option, so we have Oracle as option. And there's a requirement that definitely need to use Oracle. And there's an Exadata for Oracle. So the 6 unit of rack structure can be managed. So with that, we can manage 20,000 QPS. So we somehow try to support based on that, but as MySQL, so we would like to extend the coverage as much as possible to match with the high capacity needs. But so far, so there are cases that we need to have a rack structure to support. Understood. Thank you very much for that. So this is a circumstance of the line side. So basically, based on BM, and that is not sufficient, then there's a physical machine. So it's outside of the as a service. So DBM needs to manually structure. And we call legacy for the manual one. So we have a very old HA tools that I can never mention names. Name is used for that purpose. So basically, so by different size, by different flavor. So if we click on the image, then it starts provisioning automatically for as a service part. But in order for us to do the servicing on our own, so when was it? The Kitagawa-san has created around September, right? So it was around August or September. Yes, we developed this one. So it's past the CPU. So the history of the CPU that we are using is being accumulated. And so from there, if we are to migrate to DBaaS MySQL, then we create API that returns so that we are able to have a flexible move relocation. So there are many different types. So it looks like this. It's too small. I have difficulty seeing everything, but the size of the risk is like from 100 to 300, from 500 to 1 tera, 2 tera, 3 tera. So number of CPU for prod, it's 4, I guess. 4, 8, 16, 20. 28 was newly added recently. And the biggest memory supports until 240. So if we can manage to exceed 10,000. So the earlier table, so when I received beforehand for the flavor size, 3 tera for SC is a maximum. But if it exceeds 3 tera, what happens? So whether we ask for sharing or have 4 different DBAs so that we can divide into 4 or shift to the physical machine. And so it's going to be outside of the as a service, then we need manual building. So the box framework needs to be ordered or supplied from tool so that we are able to manage beyond 3 tera. So we have a question. So in the database selection, what's the percentage of the respective DB being selected? So it's a question to Sato-san, I guess. So in case of use, so it's mostly MySQL that people consult. So 80% of the time it's MySQL. But this is, if it's apparently KVS, so we had better use Cassandra. Or they simply want to store session information, then we can use Redis. We can guide to go to Redis. But there's a capacity needs to use Oracle. So 10% for Oracle and Cassandra, Redis 5% maybe. So 80% of the time it's MySQL. So for the selection of the database, so they want to do the relation process. So that's the basic consultation I receive. But actually, it's not a single DB, but for a certain part, Redis to be used. And for other part, MySQL can be used. So there is such combination I propose. So this is the importance of that our organization exists. So across PU, we can collaborate each other and consult so that we can build the best platform and engaged in the design. So this is exactly the interesting project that we are working on. Thank you very much. No other question? No more? Moving on to next one. So we want to be proud of the great point about the environment. So please mention the strong point. So for the PXC, so I already touched upon it briefly. But for Yahoo, so we had a manual building. So master replica has been operated over time. So for us to operate MySQL, what is an important point? So that's what I considered to come up with the priority.
And then we decided to use a cluster type. So as you can see on white color, so multi-master. So there will be no failover switch in this multi-master. So it's simply changing direction of the master. So it's master change. So there's no instantaneous stoppage. And the multi-location, that is the next point. At the time of disaster, so it can serve the recovery purpose. And in Yahoo Japan, there are 3 locations, and we are able to have it at each location. So by having this, you have a disaster recovery setup with 3 units. So that is another advantage. Well, in reality, do you have it as the disaster recovery? Well, there are different tiers in Yahoo Japan, so we are able to choose. So in one location, we can put 3 units. And then higher tiers, for example, news. Those who are in the higher tiers, so even one data center goes down, that the service must be maintained. Such a case that we have distributed locations in 3 locations. So extra DB cluster, if there's an insert and update in one node, then binary log, relay log, propagate, and then complete commit. Therefore, cross data center, well, it's like a semi-sync. So if you cross over data center, so latency will be compromised. Exactly, yeah. But still, the service needs to be maintained. That's right. So it really depends on the level of the tiers of the service provisions. So people can choose. Therefore, if they don't need any service in a higher tier, we can have the 3 units in one data center. But they can choose. Yeah, that is good. They're able to choose. Right, so if we start with this, latency is a problem, and QPS will go down for sure. So 3 units, 3 nodes. So from application, how do you access these 3 nodes? Well, we have a BIP embedded to 3 units. The routing, there's a BIP routing to 3 units, so you do not know where it is connected. Sometimes it's faster or slower. But that is something that we need to solve in the future. But the location with the application and the location for database, such a case we can't have a good latency. So applications, if they reside in the data center, you can make with the same VIP. Yes, that's good. And then what? And also availability says. So we are able to provide maintenance rolling base to improve our maintenance work. So when it comes to the maintenance for database, well, it's quite challenging to do coordination. So when to stop, we need to really make a lot of arrangement. For example, if you want to make it stop for 30 minutes, you make a lot of effort to coordinate. And if you need to stop for like 3 hours, then we need to wait maybe for a month or so. Yeah, that's happening in VM. Hypervisor memory, when it's replaced, such a case we need to contact each person for each VM, each person in charge of the VM. So that on time synchronization is a problem. And if there are 3, and you can actually stop 1 unit out of 3. Exactly, yes. So one node is a standby mode. So one node is not connected with service. So VIP is basically referring to 2 nodes, and if one goes down, then standby hosts will be also routed to standby node, or the standby node will be connected when 1 or 2 goes down. So always we have 1 node in standby mode. Therefore, so we can provide maintenance work for standby node, and you can just go one by one in turn, then you don't need to stop on this. It's an n plus 1 in the right meaning. Exactly. So this is the reason why we have this configuration. Okay, that's good. So I believe with this we are able to reduce time required for coordination. Maybe we're running out of time a little bit. No, that's fine. Don't worry. So this is about line. We have async replication. So we have primary and standby. So the 2 unit is a minimum configuration. And endpoint. For the guest VFGPL in DBaaS, you provide VAP, but we provide through the DNP to assign one endpoint. Then it's always connected to primary. This is not a VIP, but DNS linked a record and primary machine IP address, physical IP address is assigned. And we are able to scale the read replica. And at least we need to have the 2 read replicas. And standby is purely a standby, so application will never the reference to standby. Of course, we take a backup from standby. And if you take out the replica, then DNS name will be resolved by primary IP address and also VIP for read replica. And VIP can wrap the multiple read, and then VIP record will be sent out to end user. So standby side, usually we take backup from standby, and when primary goes down, then either standby or read, the ones with the latest information will be advanced to primary. So this is a same thing, therefore we are able to minimize loss. So in principle, if one goes down, then it will generate another VM and then restore the backup, then wait until it's catch up with the primary. That is how we operate. And I have one more page. That is something that we can proud of. So we have Vada. This is for private cloud. So our DBaaS for MySQL is closely coupled with Vada in order to maximize its capacity. So the MySQL health check, if this fails to the source, then from Vada API, the VM will be shut down. Then avoid split blame. And also the replica, when it's added, then second must be monitored within 5 seconds. Then it's going to the read replica. So the load balancing is being done through the Vada. And also when the going HS, so change the topology. So here the VKS okay. It's in the beta platform, so growing HA availability is a VKS platform to be assured. And also to share backup, we have a storage in there in VFSS. That is our also proprietary tool. And then when you add, well, this is a network file system. Of course, they will transfer. However, we don't see it on the surface, so it doesn't like the restore and taking backup. But it's actually computer restore, and then it's generated, and then if directly mounted, then it's restore automatically by itself to join the cluster with data necessary. So that is how it's configured.
So I like this. So simply hitting the API, all the operation is made possible, right? For the administration and the return to the backup and the operation of the failover as well. So simply from the API, you're able to enable those operations, yes. But this spec itself to be fully understood, otherwise the operation is going to suffer. So it's going to be a big work for the operation. So there are many hidden points. So it's a black box from our perspective. So flash read top with, so if we hit, then it's going to be treated as a HA going down. So we fail writing heartbeat. So the system will go down, I guess. And in case of too many connection, the system will go down. There are such case the other day. So if there's any limit for the ceiling or how long, so once it reaches a certain connection volume, then so there's a health check being thrown from Glane, and if the connection fails, then it's considered down, so failover will start. So there are too many hidden information. So unless you know the spec, you will come up with such a big problem. So we are coming to the closing point soon. So the weakness. So pain point in our environment. Sato-san, please. So it's not about PF itself, but with the DB team and cloud development team. So we have a separate team. So from the hardware perspective, the cloud development team has a OpenStack. So within OpenStack, for DBaaS, so there is a separate tool. So we have a separate component used for the operation. And so there is a circumstance of OpenStack, and for the network related areas, so we need to follow that. So I'm not sure how to put it, but so of course there's a strength, benefits, but it's quite difficult to do the full customization. Yes, it's impossible. But we appreciate this a lot, so maybe it's not the weak point. But based on what we have, the monitoring PF, so there are many things ongoing in the company, but for the logging, it's a Splunk, and metrics is watched by Grafana. And for observation, we have a SenseGo. So this is an observation tool. So we are able to set the threshold and do the monitoring checks. So we are watching different tools for monitoring. Moving on to next. So if we don't use DBaaS, then as shown in the first slide, so it's only Oracle that can accept. So QPS 1000 and 1 tera as capacity was not sufficient, but based on statistics, 80% of the time it satisfies. So it's within 1 terabyte and QPS 1000, but 20% of the time, so it's very heavy and critical DB. So we need to have a strong response to that. And because of this situation, we spent 2 years to launch V2. So we are able to select V2, so we are able to solve the situation. And the overall challenge of the MySQL, so alter system operation. We are able to manage online more and more, but it's not flexible as Oracle to change the spec. So for DXC, the cluster is going to be blocked altogether for DDL, right? Yes. So basically it blocks. So we have a complicated procedure to follow so that we can manage one by one. The rolling scheme upgrade is the procedure we are following. So you set a certain method and so stop the synchronization of DDL once and change the definition. So we need to run the process 3 times. So it's a complicated procedure to follow. And only database team cannot manage to do everything. And so we need to create a very long list of operations to follow. And if we request that, then people make mistakes and caused accidents. So we had many of those situations. So it's a challenge. Okay, so it's our turn. So change of the database. So we call workflow. So the change management or the audit of the change, we need to keep record. And the unit of application for that is one cluster. So one primary lead replica. So we can issue based on that unit. So if we are to add user from the screen, if there's a 32, then we need to open 32 tabs and input the same information for each tab. And if we miss one, then it's going to cause accident. Okay, omission of one user will cause accident, right? So this is the biggest weak point. But we are able to improve the situation, I guess. And as a service, because it is as a service, there are weakness. On the Glen HA side, they are not going to hand over the authority. So the performance scheme access role or authorization does not exist, and global authority is prohibited. So in order to hit a certain DB status, then you need to have a certain role. So even though you want to view, but other than the root account, so people are unable to use the account or create account themselves to access. And the metrics. So we are able to gather, and it's being united. But since it's united, so DBAS format is using repeatedly. So just for our DBAs, so we are unable to manage to make the interval of monitoring to, for example, 30 seconds. So minor adjustment is difficult, right? Yes. So we can easily crush, but the minor management is difficult. So and the customization. So if we want to monitor certain value, it cannot manage. So whether input everything together or no input at all. So we need a progressive resolution. We are able to gradually resolve, but so because it is as a service, we cannot avoid this problem or challenge. So based on those weaknesses, what is future in our environment? So for the next generation DBaaS perspective, the flexibility should be added. Right now, we have fixed 3 units. Within DC, we want to add one master within DC. Or maybe we can add replica. So we assume 9 units at the maximum. So especially for the read replica to be added. So we are able to realize KPS for the reference purposes. So this is something we are tackling right now. From DXC, MySQL group replication. As a group replication will replace MySQL, right? And the version is MySQL 8.0 GRL to be used. So for the group replication, GTI can be used. We are using GTI can be used. GTI remote mode is used for the operation, so we will continue to do so. And other point is GSLB. We are able to, we should create multiple of that. So just for the data center, we create GSLV so that we can guide for that location only. So we are able to create only one VIP. And so we want to enable multiple creation to increase flexibility. That's what we have in mind. So we want to be released from the clicking on the screen. So from the planning, implementation phase started. So there's a cluster, so a theoretical one. So shadow 1, 2, 3, and 4 of a certain cluster. So we can add user altogether at once, or so we want to keep it record evidence.
And also in the platform side, if change is difficult, in such a case, we are able to customize the tool, creating a tool, and in the Verda, we use an authentication from Verda. That is something we are envisioning right now for real-time monitoring for OSS, the MyStatus Go, and also PT online schema change or Ghost or 8.0 instant add column. So which one will be the best? So will be automatically decided, and then it will say version will be also reference. And so it's a safe DDL. So this is a proprietary DBL, and also as Harashi mentioned in the previous session, taking up 40 minutes to explain. So the data's been taken out and shifted to the new one for migration. It's an upgrade helper, right? It's 5.6 to 5.7. Switchover was the primary purpose of the project, but that too is used for different migrations. So to the Vada, we can push that to the Vada. So we are approaching from the two different points. Okay, so I think we are 1 minute behind only, but thank you very much. Anything that you want to say before we close? Well, this is supposed to be a panel discussion, right? But this is like dialogue rather than the panel discussion. So, and also Harashi-san also joined us. So thank you very much. So Yoku-san was a very good moderator for our discussions. So that was good. Yeah, actually, when it comes to this topic, we can speak more. Maybe 1 hour is not long enough for this topic. But anyway, time has come, so let's wrap up for our panel discussion.